Welcome back to another exciting day of integration, area between the curves. Today we're going to look at areas that are created from graphs or functions, but that we have more than one area that we got to find more than one region that we have to find the area of. So an example, maybe we have a nice cubic that comes through here, and then maybe we have a linear function that comes through like this. And notice we've got the area we have two areas, two regions that we've created. And as I look at my top versus my bottom, in this region, my top curve would be that cubic, my bottom curve would be the linear. But in this region, my top curve is a linear function, my bottom curve is that cubic. So we got to be very careful now to figure out where that line is going to be changing. So I'm going to have to find, and I'm very interested in this point here. Because now if I integrate, I'm going to integrate from A to B here. Maybe we'll call this linear function f of x. We'll call this cubic g of x. So my integration would be from A to B. My top curve is that g of x function. So g of x minus my bottom curve, which is the linear, or f of x dx. And to that I would add the integration from B, we'll call this maybe to C. My top curve now becomes f of x minus g of x dx. So we have to be, again, very careful that we know where that point of intersection occurs and which curve is on the top versus which one's on the bottom. Otherwise, it's going to cause us a lot of issues and we're going to get an erroneous solution. So let's go ahead and look at a couple of examples here. Example 1 is going to be f of x equals x and g of x equals 0. We're back to the y-axis, or the x-axis, sorry. Back to the x-axis. So f of x equals x is a linear function, nice diagonal there. G of x is 0, which is the x-axis. But we're going from -2 to here 3. So hopefully we see that from -2 here to 0, our top curve is at g of x, our bottom curve is f of x, but from 0 to 3, that switches. Our top curve now becomes f of x, and our bottom curve is g of x. So our integration is going to look like -2 to 0 of 0 minus x dx. And to that, we're going to add the integration from 0 to 3 of that x minus 0 dx. And I'm going to show you today on how to throw this into the calculator so it makes your life a little easier. So what we can do is if you click the math and the 9 button with your 84 calculator, we can integrate from -2 to 0 of 0 minus x, which is just the negative x dx. And to that we can add the integration, so another math 9, from 0 to 3 of x minus 0, which is just x dx. If we click enter, that's going to give us our area so that we can use, and we don't have to do all that math. Now, if you don't have the 84 and don't have that program, you can do it on the 83. It's a little more cumbersome. If you look it up on the internet, it'll show you how to put it in. I don't have one to show you on, or I would. But our area then is 6.5. Again, you could do this by hand, but I'm going to allow you to use that calculator program to make your life a little easier. So now I'm going to go ahead and look at f of x equals x squared plus 2x minus 3, g of x equals 0, from -1 to 2. First thing I'm going to do is put this in my calculator. So I'm going to look at x squared plus 2x minus 3. I can go ahead and plug in 0 if you want, doesn't really matter. But we're looking at this graph. So we're coming down here, coming back up. So we're going through 1 here. We're interested from -1 to 2. So we're going to go from here to here. Again, we should see part of this below the x-axis and part of it's above the x-axis. So my integration is going to go from -1 to 1. My top curve was 0 minus my bottom curve, which is x squared plus 2x minus 3 dx. And to that, we're going to add the integration from 1 to 2. My top curve, again, is x squared plus 2x minus 3 minus 0 dx. So what we're going to be able to do, if I go into my main screen, is go to Math 9. I'm going to go ahead and put in my -1 to 1. I have 0 minus that function, so I'm going to have a negative of that function. Well, that is y1, because I just put it in my calculator. So if I click on this vars, and I go over to y-vars in the function, I can recall y1. So now I have the integration from -1 to 1 of -y1 dx. To that, I'm going to add the integration, so another Math 9, from 1 to 2. Now I have my y1, or my original function, minus 0. So again, I can go to vars, y-vars, function, recall my y1, and that's going to be minus 0, or just y1, in terms of x. And that gives us 7 2/3 as our answer. Now, as I look at your work, I'm going to look to make sure you have this integration set up. You don't have to integrate it by hand unless you want to, but I'm looking for this and the graph before you submit your work, or before you get credit for your work, just so you don't give me an answer. All right, last but not least, we have the integration. F of x equals x e to the x squared. G of x is going to be 0, and we're going from -1 to 2. And I'm going to go ahead and go to my y equals. I'm going to go ahead and clear my y. I'm going to type in x, and then my e to the x squared. I'm going to graph that. I'll sketch a graph for us. This is an interesting graph, I think. Kind of looks like a cubic. And we're going from -1 to 2. So here's 1, -1, here's 2. We're going to go ahead. Oh, don't need to do that. We're going to set up our integration. Again, I want to see the graph. I want to see your integral set up. It's -1 to 0 of our top curve, which is 0, minus that bottom curve, x e to the x squared, dx. And to that, we're going to add the integration from 0 to 2 of x e to the x squared, dx. Again, I've already got this x e to the x squared in y1. So we have 0 minus y1, or -y1, as we put in our calculator. So again, I'm going to go to Math 9. I'm going to go from -1 to 0 of negative vars, y-vars, function 1, dx. And to that, we're going to add the integration, so Math 9, from 0 to 2 of just y1. So vars, go to y-vars, function y1, and that's in terms of x. Go ahead and hit our enter, and that gives us an answer of 27.658 approximately for our area. Happy integrating, and enjoy using that calculator. Again, remember, I'm looking for the integration setup and your graph.